Hi YouTube, in this video we'll test a mining GPU riser versus plugging a graphics card directly into the motherboard to see if mining risers can provide a convenient way to attach many GPUs to one machine. The scenes you're seeing on the screen are scenes that I have rendered myself, and they take hours and hours on multiple computers, and they would take days or weeks on a single setup. So this test will show us if the technology that miners use for GPU mining of cryptocurrencies can be applied to 3D rendering without any sort of performance hit. Okay, this is the PC we're going to use to test. The specs that are important here: we have a Z590 Intel motherboard with a 10th generation i5. That shouldn't matter too much for this test, but it's a modern CPU, so it's not going to hold us up much. I have 32 gigabytes of G.Skill RAM that is 3200 speed and super low latency. I think they're flat 14 timings for all the RAM nerds. In configuration 1, we're going to test our hybrid EVGA 3090 plugged into the main GPU slot. Might be kind of hard to see in the dark there, but this is in the primary PCIe 16 slot. And so for the first test, we're gonna see kind of what a baseline is if your GPU is plugged right into the motherboard. For the second test, I'm going to take the exact same GPU out of the slot in the motherboard, plug it into this mining riser. Electrically, it's only one lane, but it's a full 16 lanes physically, so the GPU will slot in. The riser has to be powered, and this one's powered by a 6-pin GPU power connector. And then for the riser to talk with the motherboard, it uses a USB cable with a 1-lane PCIe adapter on the end, and that will slot into the motherboard where the GPU normally would. And then the GPU just clicks into the riser like this. And I'll have the GPU just sit next to the case, but it's best to put it in a frame. Here's the setup for the second test. It's pretty janky. I wouldn't recommend running your machine like this all the time, but you can see the card's powered on, and Windows recognizes it just fine this way once everything's powered up properly. This is the render that I used to test. It's 210 frames, and it's just a simple fluid simulation that I have made before. In the first test, I have a RTX 3090 plugged into the motherboard using the full 16-lane slot, and this took 53 minutes to render the scene. In the second test, I have the same card, but plugged into the single lane mining riser and powered with external power. And that took 60 minutes to render all 210 frames. So as you can see from this test, it doesn't really matter if you use a riser or plug the GPU into the motherboard. In this exact test, the difference was about 12%. And that is because on the riser, every time a new frame is loaded, there's some amount of data that has to be uploaded to the GPU. And that process is slower since there's less bandwidth on the 1-time slot versus the 16-time slot on the board. In future tests, I'll probably try using a lot faster frames and a lot slower frames so that I can see if the loading time makes a bigger impact depending on the type of animation you have. If there's other tests you would like to see, let me know in the comments. Consider subscribing, it helps a lot, and that way you can follow the future videos. Thanks for joining me today, and I hope to meet with you again.